Most GIS tools struggle when your data gets big. Millions of points, thousands of polygons, and terabytes of rasters. Suddenly your desktop freezes and your workflow grinds to a halt. That's where Apache Sedona comes in. Sedona brings scalable geospatial processing to Apache Spark, letting you run spatial joins, clustering, and raster operations across massive datasets in the cloud, and helps you do true cloud-native geospatial. And Sedona just added a really interesting new tool for those looking to just get started. But like every tool, it has its strengths and limitations, the right ways to use it and the wrong ways. So let's break down exactly what Apache Sedona is, what it's good for, and when you should and shouldn't use it as part of a modern GIS workflow. Now, Apache Sedona, which is formerly known as GeoSpark, is a cluster computing framework for geospatial data that's built on top of Apache Spark. Now, there's a lot of terms there, so let's go ahead and break down what each of these things means. So cluster computing basically means taking a computing process and splitting it into smaller parts. Data warehouses and many other systems use this, so it's a pretty common framework today, and Spark is an open source way that allows you to do that. So kind of think of it as an assembly line. Instead of one person that's building a car from the beginning to end, it's like multiple people working on different parts of the problem at one time. And because of that, you're able to output or do or produce more with that process. In this case, instead of cars, we're talking about data. So it takes a data problem, splits it up into smaller parts, and then reassembles it at the end. Now, Apache Spark is an open source framework to do that. It sort of evolved out of other previous versions, but it's kind of won out to be one of the best platforms for doing this. I mentioned that data warehouses do this as well. They have that, but that's generally like a proprietary system. Spark lets you do all the configuration and build it the way that you want. You can run it on your computer, in the cloud, wherever you want to do that. And then finally, Apache Sedona is the geospatial sort of partner to Apache Spark. You can kind of think of it like PostGIS is to Postgres, where Postgres is the database, and then PostGIS is the spatial extension. Apache Sedona is the spatialistic extension of Apache Spark. But Sedona works with many other systems as well, as you can see here, so you're not limited to just using it there. And like I mentioned at the top of the video, Sedona just added some new functionality for a single node service that effectively allows you to do this with just Python and install it and get started using spatial-like functionality right on your computer. Now, Sedona brings spatial types and functions to Spark SQL and PySpark. Spark SQL and PySpark are languages that Spark uses to run its processes. There's other languages as well, but those are the two primary ones we'll talk about today. So that includes the geometry and geography type, as well as raster data and other functions to support all those different things. There's over 300 functions to date, and it's pretty close in terms of, functionality coverage to PostGIS. In fact, it's one of the most advanced for like one of these large processing systems that exists. I mentioned that it handles and reads in both vector and raster data, as well as some climate data types like NetCDF. So you can read data from many different sources, be it shapefiles, GeoJSONs, even things like CSVs, as well as cloud native types like cloud optimized GeoTIFFs, as well as GeoParquet and other different data types. And the key is that it can do it at large scale. It can read it from data locally, from data in the cloud, wherever that might be, and it can do that with pretty large volumes. What's interesting is that it doesn't actually pull the data down, it leaves the data where it sits. So it's very separate. That Spark and the processing system are completely separate from the storage. They're two completely different systems. Now, it reads in all these formats, but also outputs data in different formats, primarily cloud native formats. You can produce raster data from this. You can produce cloud optimized, formats such as GeoParquet, and do that really efficiently and at scale. So if you ever have tried to produce these really massive cloud data sets, Sedona is a very, very efficient way to actually do this. It's very scalable and allows you to have this not just an entryway into cloud native geospatial, but one of the most efficient ways to do that as well. So you can kind of think of it like PostGIS for big data problems, right? That's the one of the easier ways to think about it. Or if you're coming from Python ecosystem, it's like GeoPandas plus Rasterio, but for really big data. So that's like an easy positioning if you're coming from those systems. That's a really great way to think about Apache Sedona. So now, why should you care about Apache Sedona? Now, the first point is scalability. Scalability to me can mean many different things. That could mean just a pure number of rows or the volume of data in terms of gigabytes or terabytes, or whatever that is. But to me, it also means complexity. So if you're running things like an area-weighted interpolation, trying to figure out, and split the polygons and then add those up based on the area they're overlapping, or if you're doing some interoperable functions between raster and vector data like zonal statistics, if you try to do those operations in things like DuckDB or Python on its own, even in PostGIS in some cases, you can kind of see where those cracks start to show. And if it's crashing your system, that's one thing to think about, is hey, that's a place where I can use Apache Sedona. But of course, a lot of people think about scalability, they're just looking at number of rows or data scale, and certainly Sedona starts to really solve those problems in an efficient way. Now, integration is another key point. It works inside Spark, but as I mentioned, it works in many other systems as well. So now you can bring your geospatial data alongside other processing systems. So if that's like, log data, IoT and sensor data, finance, human mobility, or, sensors from cars and vehicles, stuff like that, even climate data, that can all kind of live in one place. So if you have data engineering workflows that are already existing there, or if you're a data engineer yourself and want to bring in geospatial data, Sedona is like the easiest way to get started with that. But integration for other systems, now that you have produced that data, you want to bring it to other places, right? You want to bring it into PostGIS or maybe, data science with workflows in GeoPandas, Rasterio, or into a data warehouse. That's all enabled by Sedona. You can build these pipelines that allow you to do that. So, really start to think about it as like, if you have that data processing problem where there's things that are taking forever to run, Sedona is like the tool that can come in and solve that for you really efficiently. Now again, raster plus vector. I talked a little bit about data warehouses before. You can check that out in this video, but data warehouses are great for vector data, and they're really good with this pre-produced analytic ready data, which Sedona and Spark are really good at producing, right? Now, but the same problem at the same time is that those systems don't support raster data or climate data or anything like that. You would have to vectorize and do all that stuff. You can do all of those sort of interoperable joins and processing right in Sedona. So since it supports both raster and vector data, it's really efficient and able to handle that. And it's really unique among like an open source distributed framework. It's like the only one that I know that can really handle it at that scale. Again, it's cloud native. Like I said, you can run it on your computer with Spark. You can use SedonaDB, which is that single node service that I mentioned, to run and do some testing. But you can also bring it into things like, Spark services like AWS EMR. You can do this in Kubernetes or your own Spark cluster. You can run it on Databricks, or you can use it on Wherobots, which is sort of an out-of-the-box service that does all of this with no kind of extra setup. But again, when I talk about cloud native, it's one of the best systems to output and produce cloud native formats. There's lots of ways to produce cloud native data like GeoParquet or cloud optimized GeoTIFFs, but Sedona is the way to do that really at massive and large scale, or for, once again, complex problems. And of course, I would be remiss to talk about AI and machine learning, right? Sedona is really good at producing these pipelines that have data that can be used in AI and machine learning and things like that. So it can prepare, do transformations and spatial data sets, and it can really scale for downstream machine learning models, or things like doing geo AI and imagery and detection and stuff like that. It can help do the processing there, and even into producing data sets that can be used in LLMs and different places. You need a lot of data to do that, and Sedona is a great way to do that. So now let's talk about if you need it. Now I talk about this in 4 different ways. The first is around personal projects. If you need to do consistent data processing, right, and you have those scale problems that I mentioned before, it's something you might want to take a look at. Now, if you don't have those problems, then you don't need it, right? If GeoPandas or PostGIS or Rasterio are meeting your needs efficiently, then you should be okay. But once you start to creep into that scale, you notice things are taking a really long time, or you're doing some processing, that's one way to explore it. So it's kind of hard to say like if you absolutely need it, but if you do hit those things, you should definitely take a look at that. Now, again, for one-off projects, kind of the same type of thing. If you're, processing a large amount of data for that specific project, then you absolutely need it. So if we look at it from that perspective, it's like a yes, I would definitely consider it. You can also take a look at SedonaDB. That's like a little bit of an easier setup. If you don't want to do the full Sedona plus Spark setup, then that gives you an easy way to just go ahead and get started with that. Now for small teams, usually the benchmark, the line you cross here is if something like PostGIS or DuckDB, or something like GeoPandas or Rasterio is starting to just hit limits for you, right? That's something you need to be aware of. It can also have some like enterprise capabilities built in because it works off of S3 data and stuff like that. So it's really great for that, but it's particularly good for things like mobility or movement data, remote sensing, even climate data analysis or stuff like that. When you have those larger data sets and you need like a backend that's pretty consistent, and those tools are just starting to kind of not do it in the right way, then you can certainly use it there. And it has a lot of those kind of capabilities built in, especially when you lift into the cloud. Then you have all those kind of like team-based things that you want to have in place. Now for enterprises, again, it integrates with big data lakes. It works with different systems like Databricks. Wherobots has integrations in different places with Apache Iceberg, has the cloud data warehouse integration, and has all these machine learning pipelines built in. I think for even small teams, but definitely for enterprises, it becomes a pretty critical part of the spatial data stack that you want to bring into place. So once again, for all these these things, let's assume that you definitely need that processing. You've kind of crossed that line and you determine, hey, these processes are taking too much time and you want to explore it. Let's first kind of take a look at personal projects. I would give this like a 3. You know, unless you are really like, you know, okay waiting around, you definitely want to put it into place. So maybe like a 3.5 in this case. And for one-off projects, again, if you have that large processing, 3.5, you definitely want to put that in place there. If you don't have those needs, then, you know, you don't need it. It's definitely, you know, kind of something that is a little bit overkill. In that case, once again, check out SedonaDB. It can actually give you a nice boost over the hill there just to go and get that. So I'm kind of including that in my metrics, even if you're not using it and you have some processing, you're starting to hit those limits. Either the options of the full Apache Sedona plus Spark or SedonaDB would be really good. So for those, let's give it about a 3.5. Again, if you are not hitting those processing limits, then you know, you can probably keep going with what you have. Now for small teams, it's really a really good piece to add into the stack. I would give it about a 4 as well. Again, if you're crossing those limits, this is the right place to look at. If you're kind of getting pushed into looking at other systems like a data warehouse or something like that, this is a great time to like, hey, suggest that, give it a try. It's open so you can test it and see how it'll go. And then that code can lift and shift in the cloud platform. So it's a really good way to test and experiment. And then for enterprise, I pretty much give it like a 4.5, especially if you have those big data problems. Plus it brings in all the integrations and stuff like that. So for the teams, you know, that connectivity into all these systems that we've already talked about with PostGIS, even connecting into QGIS and then getting into your data science workflows, it just gives that really nice piece to know that you're not going to have data limit problems and you can scale pretty efficiently. Now, how do you use it? You can actually first install Spark. There's a full video tutorial here that walks you through everything to do this in the full open source setup. So you can go ahead and check that out. But basically to actually install Sedona, it's just pip install Apache Sedona. There's also the SedonaDB extension, which is basically that single node service where you don't need the Spark backend. And you can see how to do that. Here, it's just another Python install. So basically the first step is get that Spark set up. If you don't want to do that at all, you can check out some of these cloud services. Wherobots is a great way because you don't actually have to install or do anything extra. If you went with EMR, Databricks, there are some extra steps involved in that case. Now from there, you basically get access to run things in PySpark. PySpark kind of works similar to a GeoPandas. It has its own specific things that it does. You might write some things in a more SQL-like syntax. So just be aware of that, but PySpark's pretty easy to set up if you've used something like Pandas or GeoPandas before. And then of course, if you want to use Spark SQL, which is, you know, a version of SQL that you can write, if you know Spatial SQL, you'll be able to jump in and start using Sedona very efficiently. And then you have access to all of these ST functions here, and then the RS or the raster functions that you can use here. Now to bring data in, you can read those different formats like I mentioned, shapefile, JSON, GeoJSON, Parquet, GeoParquet, GeoTIFFs, all these different things from data that's on your computer or data that's in the cloud as well. So it can be pulled in from both of those different places and effectively pulling them into what's known as a Sedona data frame, right? That's kind of like a Spark data frame, but it has that geometry part to it or the raster part to it as well. And once it's in the data frame, that's when you can use all these other functions. So basically you bring your data in, you start writing against it, and then you're ready to go. Now, Spark will handle the distribution of all that stuff on the back end. There's different things if you really want to dig into this. You know, you can set up Spark in different ways to have different memory components, stuff like that. There's a whole other practice to that I won't get into. So if you want to take a look, there's definitely, you know, videos about how to set up Spark, or if you're a data engineer, you probably know some of these different things. But basically that Spark, you know, that Sedona data frame allows it to distribute across those different nodes and run the jobs. And then you can actually access like the Spark interface to see how those things are running and how they're going from there. And there's a few different, you know, considerations that you want to keep into place with that. You want to understand how to partition your data frame effectively. You might need to do some broadcasting. If it's like a lopsided join, maybe have like, you know, a couple hundred features here and then a billion over here. The way to think about a broadcast, at least how I've started to think about it, is to say, like, if you're splitting up those billions of features across those nodes, you don't want to split up like a couple hundred features so that the node's looking at all those different places. Just send that small data set to all the nodes and then it can do it really efficiently there. So that's kind of a really oversimplified way of thinking of a broadcast. Partitioning is another really important concept here, how to split that data up. So you can do that and handle it from that perspective. And then once you've written your code or written your pipeline, you can basically pull that into cloud environments. You know, like I mentioned, some of these Spark-based ones, I mentioned Wherobots. There's lots of different ways to easily lift and shift that. At the end of the video here that you can see, actually pull all that data into Wherobots. You can actually, you know, show how you take the code, lift it in, and then you're ready to pull that into the cloud. Now, of course, we want to talk talk about pitfalls now. There is like some complexity here. You do need to know a little bit about Spark knowledge. It's not like as plug and play as GeoPandas, just a simple pip install. SedonaDB is in this case, so that's kind of the caveat here. I know I'm kind of talking about two pieces together, but they're all Apache Sedona under the hood. And if you are setting up Spark, there's a few different steps, but it's pretty simple. If you've built some things in the command line before, you can do that. Setting up and kind of optimizing a Spark, instance takes a little bit more work, so that's just something to be aware of, but that is a component here to be aware of, that Spark adds some complexity to your workflow. Again, cost and overhead. Spark clusters, like, they can be expensive if you're used to doing everything locally. So you just want to be aware of like cost control and stuff like that. It works basically once you start it, it's like a running clock. It's not gonna have like this kind of like pay per query system, which other systems have, like data warehouses and stuff like that. We just want to look at the costs and understand what that is, especially when you're moving into the cloud and going from that. But once again, you can run a lot of these things locally, do local testing, make sure everything's working well before you need to pull it into a cloud system. Now, raster support is really good, but there's a lot of pieces that are coming into it, and it's continuing to evolve. It was one of like I think one of the later pieces that was added in, so it's really good for like resampling and aggregation and basic operation, but it's not like a full raster replacement yet for things like GDAL or X-ray. But more pieces are coming in that can help that. But if you have raster data that's ready to use, it's a great place to bring that into the vector data system. Again, it's not always going to be faster, right? For smaller medium data sets, things like PostGIS or DuckDB, even GeoPandas may kind of outperform it because of that overhead. But there's certainly like a point of diminishing returns for these other systems, right? And that's what you really want to be watching out for. If you can see like, hey, this is taking really long, you really want to consider, okay, where should I move that and how should I bring that in? Now again, when should you not use it? If you're working with smaller medium data sets, you can use things like PostGIS or DuckDB or even GeoPandas like before. Once you hit that point of diminishing return, then you want to start bringing in Sedona. And again, even for these small and medium data sets, SedonaDB is an absolute game changer that you can bring in and allow you to scale that. It's really efficient. It's built with a Rust backend, which is if you're not familiar with all the things happening, Rust is kind of like the new hot language. And I think that it is allowing you to do a lot of things at scale and do that just in a single node without any sort of other backend. So if you need to do deep raster processing, things like classification or some heavy sort of ML operations, there's different things you can bring in. You want to use like X-ray or Rasteria or TorchGeo, but you can do some of the kind of simple processing and things like that. There's certainly map algebra tools and functionalities within Sedona, but it's kind of like one of those things where you can bring in some combination of pieces. But if you want to do all that together, Wherobots kind of puts all that together in a cloud system. So it's Sedona plus those types of tools all in a cloud ecosystem and stuff like that. But Sedona alone, use some raster processing that's like really significantly heavy. You might bolt it on with other tools as well. Now again, if you're doing interactive GIS editing or cartography, this is a backend tool for data processing. It's not front end. If you want a database that works with like interactive GIS, that's where PostGIS comes in. You can learn all about that here in this video, but that's another thing that you want to keep in mind and do there. And if your team doesn't already work with Spark, and you need to do a Spark setup alone, the learning curve can outweigh the benefits. So you can certainly look at using SedonaDB to get complementary functionality, or you can use one of the cloud systems that basically helps you set up Spark and you can kind of use it from there. There's also some different parts from Dr. Qixing Wu's book here that has Sedona in it. So there's lots of different ways you can actually go ahead and get started with Apache Sedona. Lots of different tutorials. I'll include everything that you might need to know in the links below. So let me know in the comments, do you have big data processing problems with geospatial data? How are you handling it today? Or do you use Sedona already? Are you a data engineer and you're interested in using geospatial data? Let me know what you're working on below. Love to hear about it. And with that, I'll see you in the next video.